You're asked to calculate the trig function for some angles. So in this example, we're going to do cosecant of 3 pi over 4. Now, you can do this on your calculator and get the answer very quickly, but the instructions say to do it without a calculator. And you may be asking, why would we want to do that? Well, the process of finding the value without a calculator is very educational. So it's going to help you when we start working with the unit circle. So let's just go ahead and bear with me on this process. And we want to find the cosecant of 3 pi over 4. So the first step is to draw your angle in standard position. Okay, and we have an angle 3 pi over 4. Since pi is sectioned off into 4, remember now pi is the half circle, right? So if we rotate our angle from the x-axis and we rotate it counterclockwise to the negative x-axis, that is pi. And we are dividing that by 4. So if we divide it in half, we're at pi divided by 2, or pi over 2. And then if we divide that half in half, we're going to have this angle here is pi over 4. This is pi over 2. And this one here is 3 pi over 4. Okay, and then of course that brings us to pi. So the angle 3 pi over 4 is depicted here in standard position, and I'm showing the rotation there with my arrow. So here's the initial side, and here is the terminal side. Okay? All right. Now, when you draw your angle in standard position, what that allows you to do is to draw a reference angle. And the way that you're going to, or triangle, if you will, you're going to drop a straight line down. And so this is our angle theta, okay? The reference angle that goes with that is alpha. And since the angle theta lies in the second quadrant, right? This is the second quadrant. The way we find alpha is we take 180 degrees and subtract your theta, which in this case is 3 pi over 4. Okay, so step 2 is to calculate the reference angle, or find the reference angle. I'm going to write that down. Let me see, I'd prefer to use black for this. Doesn't matter, I guess, but looks darker that way. Okay, so step 2 is find the reference angle. And I did that right here. Now remember, the way you calculate the reference angle depends on which quadrant you are in, okay? So just as a review, I will go over those formulas. If you're in quadrant 1, then your reference angle is the same as your angle. So that is in quadrant 1. In quadrant 2, like I just said, you take 180, or pi, if you will. So in this case, since we have 3 pi over 4, I'm going to make that into a pi. So the reference angle alpha is 180 degrees minus your angle theta, or pi minus your angle theta. Okay. And if you're in quadrant 3, that would be down in here somewhere, you're going to take your theta and subtract 180. So alpha is theta minus 180 degrees, or theta minus pi. And finally, if you're in the fourth quadrant, your alpha is going to be 360 degrees minus your theta, or 2 pi minus your theta. So this, of course, is in degrees, and this is in radians. Okay, so those are the formulas. In our particular example, we had that alpha, because we were in the second quadrant, we're going to be using this formula. We're in radians, right? 3 pi over 4. So alpha is pi minus 3 pi over 4. Now to do this subtraction, we need a common denominator. So I'm going to convert pi into pi with a denominator of 4, which is 4 pi over 4. So this becomes 4 pi over 4 minus 3 pi over 4. So my reference angle is just pi over 4. All right. So the step 3 now, you want to calculate your function for with your reference angle, okay? So the cosecant 3 pi over 4, in other words, the absolute value of this function is going to equal cosecant of pi over 4. Okay. Now, cosecant of pi over 4, well, pi over 4 is 45 degrees. And if you're looking at the triangle, so actually, here's the triangle that I'm looking at. So I should probably, let me draw that better, just to kind of, it doesn't have to be in the same orientation as long as the angles are the same. So here's my right angle. Here is pi over 4, and this is an isosceles triangle. Because this is pi over 2, they have to add up to pi. So pi over 4 plus pi over 4, that's half of a pi. And then 90 degrees, or pi over 2, is also half of a pi. So they total pi, or 180 degrees. The sum of all the angles in a triangle are equal to 180 degrees.
Can you slide the paper down?
Oh, yes. You mean down here like this, or like this?
That way.
Okay. So this is a isosceles triangle, and because all triangles that are similar, in other words, that have the same angles, the trig functions are the same, I'm going to just work with the one that has r equal to 1, because that just simplifies the problem. And then I've got this side is square root of 2 over 2, and this side is square root of 2 over 2. So my angle, pi over 4, I want cosecant. Cosecant of pi over 4, our angle here, pi over 4, we want x over y, or if you will, the cosecant, I'm sorry, 1 over, since our r equals 1, we want 1 over y, okay? Because this is the reciprocal of our sine function. So we want the hypotenuse, which is 1, over our opposite, which is square root of 2 over 2. So we're going to go 1 over square root of 2 over 2. And this is going to be the reciprocal. And then, of course, we want to rationalize the denominator. And you're going to get 2 square root of 2 over 2. The 2's will cancel, and you get square root of 2. Now, we're not quite there yet, okay? Why? Because what we did here, when you use the reference angle, because the reference angle is in the first quadrant, reference angles are always acute. So all of the trig functions are positive in the first quadrant. So we're not really doing the sign of this calculation. We're just doing the absolute value. In other words, the magnitude. How big is it apart from the sign? So we have to, now that we found the magnitude as square root of 2, or the absolute value being square root of 2, now we have to find the sign, okay? And that's where all students take calculus come into play, right? So all students take calculus, it says that now remember, cosecant has the same sign, S-I-G-N, as sine, S-I-N. I know it's confusing, okay? Cosecant and sine have the same sign. So if sine is positive, cosecant is going to be positive. And if sine is negative, cosecant is going to be negative. Our angle that we're talking about is this one right here. It's in the second quadrant. Notice that from my little mnemonic here, all the sine functions are positive in the first quadrant. I mean, all the trig functions. Sine is the only one that's positive in the second, along with its reciprocal. Tangent is positive in the third, and cosine is positive in the fourth. So we're just focusing on the second quadrant. That's our angle right here in the second quadrant. So we know that cosecant is positive along with its reciprocal in this quadrant. So we know that our sine is going to be positive, okay? So step 3 is you're going to find the magnitude of your trig function. And then step 4, which is what I did here, you find the sine. Let me write that out. And you may be wondering, why would I want to go through all this trouble just when I could have easily used my calculator? And I get that. It's just a learning thing. If you go through this, the more you practice these sort of things, you're going to better understand what you're doing with these trig functions and with these angles. Okay, so it's really more a learning process. You can always, and also when you're doing this, your calculator, not all calculators, but most of them will give you a decimal value. And if you try to enter the decimal value in, you have to round it. It's not the exact value. And the instructions in your homework say find the exact value. So you want to leave it as square root of 2. You don't want to write this as 1.7 or 1.4, whatever it is. I think square root of 3 is 1.7. This is 1.4. So you don't want to round a decimal. You want to just leave it like this. Okay? Any questions on this? I know it's quite involved. Basically, the process, just to review, is you first draw your angle, find out which quadrant it is in. Based on that, you find the reference angle. Then you use your triangle that works for your angle. You draw a picture, and then you use the rules for your trig functions to, you know, like here we took the hypotenuse divided by the opposite. That's the reciprocal of sine. So that's how we got this. And then you simplify it. This gives you the magnitude of your function. Notice I use the absolute value. I'm just looking at the positive part. And then after you do that, step 4, you use your all students take calculus and you decide, is this positive or negative? And we decided because we're in the second quadrant, sine is positive and therefore its reciprocal, which is cosecant, is also positive. So that's where we got the sine from. So those are the 4 steps. I want to do 2 more examples so you can see how this works again. Okay.
Where did you get the square root of 2 over 2 from?
Say that again.
Where did you get the square root 2 over 2 from?
Oh, okay. So there are 2 triangles that you want to be familiar with, okay? And let me just talk about that. Okay, we have this triangle, which is the isosceles right triangle, and it has 1 as its hypotenuse. And based on the Pythagorean theorem, these two have to be equal, right? So if this is x and this is x, then 2x squared. So the Pythagorean theorem says a squared plus b squared equals c squared. Using this formula, this length is a, so that's x squared. This length is x, and that's the b, so that's x squared. And c is equal to 1. So you can see here I have, my paper keeps bumping into my this projector thing, so it's hard to, okay. So if I solve this, I get 2x squared equals 1, x squared equals 1/2, and then I take the square root of both sides and I get x equals 1 over the square root of 2, which if you rationalize the denominator, you get the square root of 2 over 2. So that means that this side is square root of 2 over 2, and this side is also square root of 2 over 2. Because it's isosceles, the two sides are the same, okay? So that's one triangle that you're going to reference. That's if your denominator is a 4. Then you're going to use this triangle. So let me write that note in here. Denominator of theta is equal to 4, okay? The other triangle that you're going to use a lot, and we'll see this more when we look at the unit circle, kind of running out of room here. The other triangle is the 30, 60, 90 triangle. So your hypotenuse is still 1, and then you have 30, this is your right angle, and 60. 30, 60, 90, right? Now, and basically doing this same sort of thing, well, I'll do, I'm going to, just to save time for right now, I'm not going to show you how I get the sides, but I'm just going to let you know that the opposite of 30 is going to be 1/2, and then the opposite of 60 is going to be square root of 3 over 2. And the way you come up with this is you take a equilateral triangle, each having side 1, and you cut it in half, and then you do some sort of Pythagorean theorem, and you get the same, you get these numbers, okay? But the point is, depending on what angle you have, if you have 30, you're gonna, this will be your opposite, this will be your adjacent, this will be your hypotenuse. And if you have 60, this will be your opposite, this will be your adjacent, and that's your hypotenuse, okay? So these two angles we're going to use a lot, and I'm going to do that after I finish these example problems. I've got 2 more to do. We'll start talking about the unit circle, okay? Any other questions on this? Okay. Thank you for those questions. Let me see, there's a chat here. Let me just check it real quick. Somebody wrote, couldn't you just convert 3 pi over 4 into degrees, subtract the value from 180 to find the reference angle? Yes, you can do that. So if you're a person who doesn't like to deal with fractions, that may be what you want to do, okay? Some people just like to work in degrees. They just feel more comfortable. I don't know why. Maybe because I was a physics major, they tend to do a lot of stuff with pi, and I don't know. I just feel more comfortable with pi. So it's just your preference. Whatever you want to do is fine. All right. So let me do another example like this, and we'll get better at this the more we practice. Okay. Any other questions on this one? Thank you for your questions. I appreciate that feedback or that input. Okay, so the next example, I want to find cotangent of 25 pi over 6. okay? And again, you can convert that to degrees if you want. My last problem is in degrees, so I will show you an example with degrees, but for now I'm just going to keep it like this. And the first step is to draw your angle in standard position. And you will notice, that 25 pi over 6 is not within the range from 0 to 2 pi. So we want to find the coterminal angle. And so I'm just going to put a note here, but first, find a coterminal angle in the right range. Of 0 to 2 pi, okay? So we are dividing by 6, so this is 6 into 25, it goes 4 times, so this is like 4 pi plus pi over 6, plus another 6, okay? So we're obviously way out of the range, so I'm going to have to subtract off 2 pi until I get between 0 and 2 pi. So here I take 25 pi over 6 minus 2 pi. That's going to be 25 pi over 6 minus 12 pi over 6, right? I have a common denominator here. 2 pi is the same as 12 pi over 6, okay? Now that I have a common denominator, I can go ahead and subtract, and I get 13 pi over 6. But I'm still out of range because remember now, 2 pi is 12 pi over 6. And here, that's more than 12 pi over 6. So I need to subtract off another 2 pi or 12 pi over 6. And that gives me pi over 6. So this is my coterminal angle. And because this is an acute angle, in other words, it lies in the first quadrant, my reference angle is in the first quadrant. So if I draw this, I have pi is divided into 6. So if I do that, I get something like pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So my angle is right here. There's the initial side, and there's the terminal side, and pi over 6. So alpha, the reference angle, is equal to theta, which is equal to pi over 6, because we're in the first quadrant. Okay, so step 1, we drew our angle. Step 2, we found the reference angle. Step 3, we just calculate cotangent of pi over 6. Cotangent of 25 pi over 6 then is equal to cotangent of pi over 6. Now remember, this, because it's in the first quadrant, all the trig functions are positive in the first quadrant. So this is going to be positive, and so we just need the proper triangle that we're going to use. So pi over 6, if I convert it to degrees, is 30 degrees. So my triangle then say this is 60, this is 30, this is 90, my 30, 60, 90. Opposite of 30 is 1/2, opposite of 60 is square root of 3 over 2. And cotangent is the reciprocal of tangent. Tangent is y over x, so cotangent is x over y, or if you will, the adjacent over the opposite. So the adjacent is right here. That's the adjacent to 30 degrees. Okay, and this is the opposite to 30 degrees. Okay, so cotangent of pi over 6 is the adjacent over the opposite, which in our case is square root of 3 over 2 divided by 1/2. And when you divide by a fraction, you multiply by the reciprocal. So this whole thing becomes square root of 3 over 1, which is just plain old square root of 3. And so that is my answer right there. Okay. This one was a little bit easier because our reference, because we were in the first quadrant. Okay, so we didn't have to worry about the sign. It's positive, and the reference angle is equal to your angle. So it was a little bit simpler to do. Any questions on this one? This is cotangent of 25 pi over 6 is the original problem. Okay. One more example. This time I'm going to do one in degrees. Okay. So if there are no questions on this one, let's do example 3, and we're going to do sine of negative 120 degrees. Okay. So step 1, draw it, but first find the coterminal angle. Okay, because negative 120 degrees is not in the range from 0 to 360, okay? All right, so I'm going to add 360 to my angle. And so we're basically subtracting 120 from 360, and that's 6 minus 2 is 4, 3 minus 1 is 2, so my coterminal angle is 240 degrees. And so we want to draw this. So it's past 180, but shy of 270. So here's 270, here's 180, so it's in the third quadrant. And 240 is, let's see, 180 plus 60. So it's going to be like right about here. So we want to find the reference angle, and if we drop a line down, this is my alpha here. So I'm going to take 240 minus 180, and that will give me the difference there, which is alpha. So alpha is 240 degrees minus 180 degrees, which is 60 degrees. That's my reference angle. Now the sine is going to, I'm going to wait. First I'm going to calculate for 60 degrees. So the triangle that I'm going to use is the 30, 60, 90 triangle. So we'll say this is the 30, this is the 60. Now remember, the hypotenuse is 1, opposite the 30 is 1/2, opposite the 60 is square root of 3 over 2. That never changes, okay? That triangle is a special triangle that we use to evaluate these functions without a calculator, okay? We are interested in 60 because it is the reference angle for this negative 120, okay? So looking at 60, we have sine. Sine of your alpha is sine of 60, which is opposite over hypotenuse. The opposite of 60 is square root of 3 over 2, and the hypotenuse is 1. So this is just square root of 3 over 2. This is the absolute value of, okay, so we found the absolute value of sine of negative 120 degrees. Now we need to find the sine, S-I-G-N, okay? So the last step is to find the sine, okay, positive or negative. So if we look at our all students take calculus, the function that we're interested in is sine. Sine is positive here and here, which means it's negative in the third and fourth quadrant, okay? So we're in the third quadrant, so our answer is going to be the negative. So that means that sine of minus 120 degrees is negative square root of 3 over 2. Okay,